In this problem, we have a 5 kilogram object that is sitting in some amount of liquid, and it is being released from rest while it is fully submerged in the liquid. So the mass of the object is given by 5.00 kilograms. The mass of the fluid being displaced by the object is given by 3.00 kilograms. Now, the question is asking us for the distance and the direction in which the object travels in a span of 0.200 seconds after it is being released from rest. We are assuming that there is no drag force acting on the object from the liquid. So because we are given a situation in which there are multiple different forces acting on the object, and we're looking to describe the motion of the object because of those forces, it looks like it's time to set up a force equation for the motion of this object in the liquid. So, on this diagram I have here, let's draw out the forces acting on this object at a given point. So first off, acting straight down from the object, there is going to be a force due to gravity, or from the weight of the block, so let's call that F sub g. It's acting downwards. And then we can also apply Archimedes' principle, which states that there is going to be a buoyant force on the object acting upwards. So that is going to be directed upwards. And let's call that F sub b for a buoyant force. Now we know that this object is supposed to be accelerating after a few seconds once we let go of it. So we'll want to set up a force equation representing this motion. It's also important to have defined a coordinate system for this situation. I have labeled mine as, I've taken the upwards direction to be positive and the downwards direction to be negative. So now let's set up a force equation for this situation. So because the buoyant force is acting upwards and is going to be the positive force here, I have written my force equation as the buoyant force minus the gravitational force, and that's equal to the total net acceleration of the object, whatever that is going to be. Now let's sub in some variables here to make it more clear how we can relate this formula to the variables the problem gives us. Now we have that the buoyant force on an object is going to be equal to the mass of the fluid being displaced by the object times the acceleration due to gravity. So I've subbed in eb sub f times g for the buoyant force, minus the force of gravity, which we know to be just the mass of the object times the acceleration due to gravity, and it's equal to ma. And this is actually already pretty close to what we're looking for. So let's just sub in some variables that we already have. And so I've plugged in the mass of the displaced fluid for m sub f, and I've plugged in the mass of the object, 5 kilograms, for the mass of the object, for just m. And so we are looking for A. We want to find out what the total acceleration of the object will be, or the net acceleration, rather, after we let go of it while it's in the liquid. So first off, we can simplify these terms that have g at the end of it by simply subtracting the number here. And this is going to be equal to negative 2g, because 3 minus 5 is negative 2. And I'm going to drop the 0.00 just for simplification here, because at the moment, those digits aren't really adding anything to our calculations. And so that is equal to 5a. And to solve it just for a, we're going to divide both sides by 5. So our left side here becomes negative 2 divided by 5, and all of it is multiplied by g. So now we have that the acceleration of the object, once we release it, is equal to negative 2/5 of g, of the typical acceleration due to gravity. So, taking this formula, and then for g just plugging in 9.8 meters per second squared, we find that the acceleration of this block is going to be equal to negative 3.92 meters per second squared. That is the acceleration of the object once we release it, but we are looking for the distance that it will move over the course of 0.2 seconds. Now we have some kinematics formulas that can help us describe motion that we can use to find the distance that it will travel. One of these kinematics formulas is the one that states that a change in position is going to be equal to the initial velocity multiplied by the time, plus half of the acceleration times the square of the time elapsed. Now in this case, the problem specifically specifies that we are releasing the object from rest submerged in the fluid. So the initial velocity will just be equal to 0, so we can ignore this term, and all that we're left with is that the change in position is going to be equal to half of the acceleration times the time squared. So now we'll just have to plug in our values in for this term here. Plugging these values into the formula, we find that the change in position of the object is going to be equal to negative 0.0784 meters. And I've also taken care to round to 3 significant figures, since that's the number of sig figs and all the other values were given in the problem. And this negative sign here tells us that the change in position of the object is negative, meaning it's going to go downwards. It's going to sink deeper into the liquid. So, to answer this question in the way that the question asks us to answer it, we can say that the object moves a distance of 0.0784 meters and it moves downwards. So this is how we would communicate our final answer to the problem.